Welcome back to the deep dive. Today, we are strapping in for something really foundational.
Yeah, foundational's the right word.
It's critical if you want to understand the modern cloud ecosystem. And if you're looking to master the language the cloud speaks, especially as we lay the groundwork for the Terraform Associate certification, you are in exactly the right place.
Exactly. For years, managing cloud infrastructure, it felt like just walking through a minefield.
Right.
All manual settings, endless clicking, and just hoping for the best. We call that ClickOps, and it's unreliable, it's slow, and it just doesn't scale.
It really doesn't.
So our mission today is to pull apart the core philosophy that lets engineers move past that chaos and into pure, verifiable, well, executable logic for building their digital foundation.
Okay, let's unpack that transformation then. Started with the biggest idea of all, infrastructure as code, IAC.
Yep.
For a lot of us who remember let's call them the bad old days of manually setting up servers in a web console, this shift can feel a little daunting.
Yeah.
So what's the elevator pitch for IAC, and why did the whole industry pivot so hard towards it?
The pitch is, it's actually revolutionary in its simplicity. You stop treating your infrastructure as a series of manual actions,
Okay.
and you start treating it exactly like application code.
So every single component.
Every component, your servers, network rules, load balancers, your databases, all of it, top to bottom, is defined in machine-readable configuration files. We are literally replacing button clicking with text files.
So instead of documenting the steps I took to build something, I'm writing a static, descriptive definition of the cloud I want to exist.
That's it. That's the core idea.
But I have to ask, if I'm a fast operator, couldn't I still launch a simple environment faster by, clicking 5 buttons in the console?
Sure, maybe for one small thing, one time.
So why is this shift so critical that it's now like a mandatory skill?
You're hitting on a really key insight there.
Yeah.
Because the primary driver isn't initial setup speed, it's consistency.
Consistent.
Humans are fantastic problem solvers, but we are just awful at repetition. Ask an engineer to deploy 20 identical test environments, and I promise you, by the 10th one, they're going to miss a tag, forget a security group rule, or maybe use the wrong server image.
And when those little differences creep in, that's where stability just dies. You mentioned a term for that kind of slow, insidious divergence.
Yes, that is configuration drift.
Right. Good.
It's the ultimate enemy of reliability. Imagine a huge outage at 3 in the morning.
Okay.
Your team is scrambling, and you find out the root cause was a firewall rule that someone manually applied to the staging environment 6 months ago, but they only applied it to 9 out of the 10 web servers.
And that 10th server, because of that one tiny manual variation, brought the whole thing down.
Exactly. That divergence costs time, it costs money, and it definitely costs sleep.
So the true value of IAC isn't that it's just fast, it's that it guarantees repeatability. If the definition file says port 80 open, then every single instance launched from that file will have port 80 open. It just removes that human error variable completely.
It does. And because we're talking about text files, actual verifiable code, we instantly get access to every safety mechanism that modern software development relies on.
Which brings us to version control. I've always seen developers use Git and GitHub for their application code. Now we're applying that same process to infrastructure.
Yeah.
What does that actually unlock for an operations team?
It unlocks accountability and safety. Think of it like this. You put your infrastructure code, your HCL files, into version control. You push them to GitHub.
Okay.
Suddenly, you have a complete auditable history of your entire cloud environment. You can see not just what it looks like now, but what it looked like 3 weeks ago and who made the change.
That's a fundamental shift in auditing. You can see exactly who changed the database size and when.
Absolutely.
Yeah.
And even more importantly, it enables what we call infrastructure pull requests. So if you, the engineer, want to change a critical security policy, you don't just log into the console and click Save.
No.
You change the code. You submit a pull request. And your peer can review the actual code changes before they're ever merged.
And if that change introduces a bug, like you accidentally open a port to the entire world?
You can instantly roll back.
Yeah.
You just revert to the previously committed known good version of the infrastructure's definition. That ability, the power to rapidly revert the entire infrastructure state, is transformative for incident response.
Okay, so we've established that IAC is mandatory for consistency and stability, but there are a few IAC tools out there.
You're on.
AWS has CloudFormation, Azure has Bicep. Why are we dedicating this deep dive specifically to Terraform, and why is it so often considered the industry standard?
This is where Terraform's philosophical advantage really comes into play. It is deliberately provider agnostic.
Provider agnostic.
Think of it as the ultimate interoperability layer. It's the Switzerland of cloud orchestration.
Ah, I like that.
While AWS CloudFormation might be deeply optimized for AWS, it can't manage resources in Google Cloud or Azure. It's stuck in that walled garden.
But what if I'm a smaller company and I only use AWS? Why wouldn't I just stick to CloudFormation? I mean, adding a layer of abstraction with Terraform, that sounds like it adds complexity.
That's a fair point, and it's the core question every engineer asks at the beginning.
Right.
The answer really lies in standardization and talent. If you choose Terraform today, you standardize on one language, that's HCL, the HashiCorp configuration language, and one workflow.
And that works regardless of where you're deploying.
Regardless. Even if you later acquire a company that runs on Azure or your marketing team suddenly needs something in Google Cloud, that consistency just simplifies training and hiring so much.
So an engineer who knows the Terraform workflow can manage pretty much any cloud service out there.
As long as it has an API, yes.
Yeah.
It's about future-proofing your skills and your strategy.
Okay, that makes sense. A single tool set for a multi-cloud world.
Exactly. And this is all enabled by a fundamental design philosophy, which is core to the certification. Terraform is declarative, not imperative.
This is a critical distinction. I know it trips up a lot of new learners. Let's really break down the difference between those two.
For sure. So if we look at automation, imperative tools are like the traditional scripting approach. It's like writing a very detailed cooking recipe.
Step by step.
Step 1, preheat the oven. Step 2, mix flour and eggs. Step 3, bake for 30 minutes. You are defining the sequence of steps the machine has to execute.
You're telling the system how to get to the outcome. So if I run that script twice, I'll end up with 2 batches of cookies.
Correct. And if halfway through someone else bumps the oven temperature, the imperative script, it doesn't know. It has no idea the state has changed. It just keeps following its steps.
So what does Terraform do differently?
Terraform operates declaratively. You don't define the steps at all. You only define the end state.
The end state.
You simply say, I want a small 2-bedroom house with a red roof.
So you tell the system what you want, not how to build it.
That's it. Terraform then looks at the current reality, the existing state of your infrastructure, and it compares it to your desired state. It automatically figures out the how, what walls to build, what to paint, what needs to change.
Okay, let's take that analogy further. I run my declarative code, and the house is already there, but the roof is blue. I run the code again. What happens? Does Terraform try to rebuild the whole house?
Not at all. And that is the beauty of it.
Okay.
Terraform sees the foundation, the walls, the rooms, they're all in the desired state. The only thing that's different is the roof color. So it performs only the one single action necessary. Change the roof from blue to red.
And that ability to run the same configuration over and over and reliably get the same result, that has a name, right?
It does. It's called idempotency.
Idempotency.
It's the technical term that anchors this whole philosophy. It means I can run my configuration 100 times without accidentally spinning up 100 identical databases, or worse, destroying existing things unnecessarily.
So that's how it's so safe. But how does it know? How does it check the current state so precisely?
It does that through its state file. When you run Terraform, it stores a snapshot of the actual infrastructure it managed in a file.
The stat file.
Yep. So when you run your code a second time, it does this 3-way check.
Yeah.
It compares your new HCL file, the reality of the live cloud resources, and the history stored in that state file. That comparison is what allows it to be surgically precise.
And that's impossible with a simple imperative script.
Totally impossible.
Okay, that really clarifies the technical philosophy. Now, let's connect this back to the business side. We've talked about consistency, but let's talk about money and governance.
Yeah, the fun stuff.
How does IAC fundamentally impact compliance and cost management?
The impact is profound, especially in big companies. Take compliance. Traditionally, if a security team needed to verify that all databases were encrypted, they would have to audit thousands of running resources, often with manual checklists. It's slow, and you're always going to miss something.
Because the running infrastructure is always a moving target.
Precisely. With IAC, the security team audits the configuration files instead of the live resources. They audit a static, pretty small set of text files. This lets them do policies as code.
So they can enforce rules before anything is ever created.
Exactly. Rules like all S3 buckets must be private, or no virtual machine can be larger than a certain size. Security shifts from being a reactive cleanup crew to a proactive gatekeeper.
It sounds like it integrates the security team directly into the deployment pipeline instead of them being an external auditor.
That's absolutely right. It turns compliance into a coding task, which is just way more scalable. And when we shift to cost management, the benefits are immediate.
I can imagine.
Everyone who's worked in the cloud has a story about expensive, forgotten infrastructure.
Oh yeah, the dreaded zombie resource story. My favorite is the developer who spun up a gigantic database for a 2-hour test.
Amen.
And then went on a 2-week vacation, leaving this multi-thousand-dollar database just humming away, completely useless.
That exact scenario is the #1 cause of unnecessary cloud spend.
Right.
Because IAC defines the entire lifecycle in code, it makes it trivial to manage things that only need to exist for a short time. You can spin up a complete environment for a test with one command.
And more importantly.
And, crucially, you can destroy it completely with another single command when you're done. No more zombie resources.
So the environment is treated as ephemeral. It only exists as long as the definition says it should. That is a huge advantage for managing budgets.
It is. And it fundamentally changes the culture of a technology department.
Yeah.
IAC is more than just a tool set. It's the shift that turns old-school operations roles into a structured, verifiable engineering discipline.
Okay, so what does this whole foundational deep dive mean for you, the listener, as you prepare for the next step? Let's do a quick recap of the 5 critical concepts we unpacked.
Let's do it. First, remember that IAC is the practice of managing infrastructure through definition files. It replaces manual, error-prone clicking.
Second, the key benefit isn't speed, it's consistency. That eliminates configuration drift and gives you radical repeatability.
Third, because infrastructure is now code, it has to live in version control. That gives you history, collaboration, pull requests, and those crucial rollbacks.
Fourth, the core philosophy of Terraform is that it is declarative. You define the end state, and the tool handles the how.
And finally, fifth, its huge popularity comes from being multi-cloud and provider agnostic, a single workflow to manage pretty much anything.
Excellent. We've covered the philosophical foundations. Next time, we move into the practical world of how you actually use this tool, diving into the 3 pillars of the Terraform workflow: write, plan, and apply.
And since we know Terraform handles the complex steps, the how of building or changing infrastructure, this raises a really important question for you, the engineer.
What's that?
If the tool is smart enough to figure out all the steps, what is the most critical stage where human review is still mandatory to prevent unwanted changes, especially accidental destruction of resources, before they happen?
A very important question.
Understanding that indispensable human oversight. That's going to be the key to mastering the plan phase.
We'll explore that indispensable human step and why the plan phase is non-negotiable next time.
Thanks for joining us on this deep dive.